In this video, we will be going over something called the unit circle. Now, a unit circle is just a circle with a radius equal to 1. Okay, so what we see here in this image is we have a circle. It's plotted with its center at the origin of the xy coordinate plane, and then the radius from the center to the edge of the circle is equal to 1. Now, we use the unit circle to help us find the sine and cosine values of common angles that we encounter in a trig class. So suppose I draw, not that line, suppose I draw this line and this line here to form an angle. Okay, so the initial side is on the x-axis, the terminal side is 30 degrees right here. Now, what I can do is I can create a right triangle with this angle. Okay, and we know that because this is a unit circle, the radius is equal to 1, meaning in this right triangle, the hypotenuse is equal to 1. Now what we want to do is we want to be able to determine what the x and y coordinates are for this point right here. So we can do this by using a combination of the Pythagorean theorem and the trig functions. So in order to find these coordinates, what we're going to do is we're going to draw a second triangle that also has a central angle of 30 degrees, and it'll stop right here. So because this is a unit circle, this distance is also 1. This triangle is an equilateral triangle. In other words, all the angles are 60 degrees. Because this is an equilateral triangle, the distance, the vertical distance, is also equal to 1. Which means that each of these short sides in the triangle are 1/2. Okay, so let's just focus on the triangle that is outlined here. Okay, so we have two of the sides of that triangle. We have 1 for the hypotenuse, 1/2 for the vertical side. If we want to find the horizontal side, we can use the Pythagorean theorem. So we could say 1 squared, which is the hypotenuse, is equal to 1/2 squared plus, let's call it x for the horizontal side squared. So I get 1 equals 1/2 squared is 1/4 plus x squared. Move the 1/4 to the left-hand side. We're left with 3/4 is equal to x squared. Then take the square root of both sides. Square root of 3 is just square root of 3. Square root of 4, and the denominator is 2. So that's what x is equal to. So this length right here is √3/2. All right, so I'm going to erase all of the work over here. And what we have is the coordinates for this point that we were trying to find. So the x-coordinate is just the the x-coordinate is the horizontal distance for that triangle, √3/2. The vertical distance is 1/2. Okay? So let's see how this relates in a trig sense with the trig functions. So if we say that, let's do some work over here, sine of 30 degrees, well, we know that sine is the opposite side over the hypotenuse. Well, the opposite side is going to be 1/2 divided by the hypotenuse, which is just 1, because in the unit circle, the hypotenuse is always going to be 1. So sine of 30 degrees is equal to 1/2. Suppose I want cosine of 30 degrees. Well, cosine is equal to the adjacent side, which is √3/2, divided by the hypotenuse. So we end up with √3/2. So what you notice here is that this value is the y-coordinate from right here. This value is the x-coordinate from right here. So a simplified way of thinking about this is that in the unit circle, the x-coordinate corresponds to the cosine value of an angle. The y-coordinate corresponds to the sine value of that angle. Okay? Let's look at tangent also, tangent of 30 degrees. Well, we know that tangent is the opposite side over the adjacent side, so at 30 degrees, the opposite side is 1/2. The adjacent side is √3/2. Simplifying this, I'm going to get 1 over square root of 3. Kind of running out of room here. But 1 over square root 3, to rationalize this, we end up with √3/3. So that value is tangent of 30 degrees. Okay? So how can we get that? Well, all we did was we took the y-coordinate and we divided by the x-coordinate. So the y-coordinate divided by the x-coordinate, that corresponds to the tangent value of a function. I'm sorry, tangent value of an angle. All right, so we figured out the sine, cosine, and tangent values for 30 degrees. Let's do something similar for 45 degrees and 60 degrees. We'll look at 60 degrees first. So we have a triangle. Actually, we want to put the 60 degrees down here, and we'll put the 30 degrees up here. Okay, so there's our right triangle. Again, this is a unit circle, so the hypotenuse is equal to 1. And we kind of saw this already, but the side that's opposite the 60-degree angle, that's going to be √3/2. And the side that's opposite the 30-degree angle is going to be 1/2. It's the same triangle that we just saw, it's just kind of inverted. So what we can do is we can figure out the sine, cosine, and tangent values in the same way that we just did. But before we do that, let's talk about what the coordinates are here. Well, the horizontal coordinate is going to be 1/2. The vertical coordinate is going to be √3/2. Okay? And just like before, the x-coordinate corresponds to cosine. The y-coordinate corresponds to sine. So if we wanted to say, well, what is the sine value of 60 degrees? Well, that's just the y-coordinate, √3/2. The cosine value of 60 degrees, well, this is just the x-coordinate, that's 1/2. The tangent value of 60 degrees, well, this is y/x. So √3/2 divided by 1/2, the 2's can simplify out, so we end up with √3. Okay, so the unit circle gives us the shortcuts for the sine, cosine, tangent. It also gives us cosecant, secant, and cotangent values for these specific angle measures. And those specific angle measures are the 30, 45, and 60. Let me clean this up, and then we'll look at the 45. So I'm going to write the 60 degrees here. That is corresponding to the central angle of 60 degrees. So it wasn't showing up as 60 degrees on that right triangle, but for the sake of labeling the unit circle, this is how we do it. All right, so finally, let's get a right triangle with a central angle of 45 degrees. So 45 degrees here. We're going to have 45 degrees up here. So when we have a triangle like this that has two angles that are the same and a third angle that's different, it's called an isosceles triangle. In that case, the two legs are always the same length. So I can figure that out by saying 1 squared for the hypotenuse is equal to x squared plus x squared. They're both x's because the legs are the exact same in an isosceles triangle. So we end up with 1 is equal to 2x squared, divide both sides by 2, take the square root, I get square root of 1/2, which that simplifies to square root of 2 over 2 when we multiply the top and bottom by root 2. Okay, so that is the vertical and the horizontal lengths in this right triangle. So let me label those here. So this is root 2 over 2. The vertical is root 2 over 2. So what that means is the values on this point are going to be root 2 over root 2. So let me do some erasing and then we'll label. So for this point, the horizontal coordinate is root 2 over 2. The vertical coordinate is also root 2 over 2. And again, that corresponds to the x and the y. So again, if we wanted to figure out the sine value of 45 degrees, it's just going to be the y-coordinate, which is root 2 over 2. The cosine value of 45 degrees is the x-coordinate, which is also root 2 over 2. And then the tangent value of 45 degrees, well, tangent is y over x. In this case, y and x are the exact same. So I get the same thing over itself, which is going to be 1. Okay, so cleaning up all that triangle business, couple things we need to mention. Well, this unit circle we can separate into 4 quadrants. We call this quadrant 1, we call this quadrant 2, this is quadrant 3, this is quadrant 4. Okay? In quadrant 1, the x-coordinate and the y-coordinates are both positive. So we see that x and y are both positive in this quadrant. In quadrant 2, any value that's in this quadrant over here is going to have a negative x-coordinate and a positive y-coordinate. Okay? In quadrant 3, we're going to have both coordinates being negative. In quadrant 4, the x is positive, the y is negative. And then the other thing to mention about what's happening in quadrant 1 is, well, all of these angles so far are measured in degrees. We want to also be able to measure these in radians. So 30 degrees is equal to pi over 6 radians. 45 degrees is pi over 4 radians. 60 degrees is pi over 3 radians. Okay, so let's figure out what's happening in quadrant 2. Well, in quadrant 2 and quadrant 3 and 4, the remaining values in the unit circle, we don't actually need to draw the triangles anymore, because knowing the fact that the coordinates are going to be the same, the only difference is whether the values are positive or negative. So I'm going to go around the unit circle labeling first some of these angles. So this angle here is going to be 120 degrees. This is 135 degrees, 150 degrees. I didn't mark down what's at this point 0, 1, but that's going to be 90 degrees. This point here is 180 degrees. Continuing on, we have 210, 225, 240 degrees. Down here it's 270 degrees. And then going on, 300 degrees, 315 degrees, and 330 degrees. Okay. I'm also going to go around and label all of these angle measures in radians. This is pi over 2. Okay. So going next, we have 2 pi over 3. This is 3 pi over 4. This is 5 pi over 6. And this is pi. Going down into quadrant 3, 210 degrees is 7 pi over 6. This is 5 pi over 4. This is 4 pi over 3. Down at the bottom of the circle is 3 pi over 2. And then finishing up in quadrant 4, we have 5 pi over 3, 7 pi over 4, and 11 pi over 6. So now that we have all the angles, we can go ahead and label each of the values, each of the coordinate values for each angle. So notice that 120 degrees It's kind of it's a reflection over the y-axis of 60 degrees. So the coordinates are the same. The only difference is that the x-coordinate is negative. And this corresponds to what we saw right here, how the x-coordinate is negative, the y-coordinate is positive. So 135 is a reflection of 45, so negative root 2 over 2, positive root 2 over 2. And then 150 degrees is a reflection of 30 degrees, so negative root 3 over 2, positive 1/2. Okay? At 180 degrees and pi, the coordinates are -1, 0. So moving down to 210 degrees, this is a reflection of 30 degrees, but in this case, the x and the y are negative. So negative root 3 over 2, comma, -1/2. 225 degrees, or 5 pi over 4, is a reflection of 45, but both negative. And then similarly, 240 is a reflection of 60 degrees, where both coordinates are negative. Okay, at 270 degrees, or 3 pi over 2, the coordinates are 0, -1, so 0 on the x, -1 on the y. And then moving along, 300 degrees is a reflection of 60 degrees. This time, x is positive, y is negative. 315 is a reflection of 45. X is positive, y is negative. And then 330 degrees, or 11 pi over 6, is a reflection of 30. So root 3 over 2, -1/2. Okay, so that is the unit circle. And what we need to know about the unit circle are all of the angle values and all of the coordinates. So when I ask you something like, what is the x value at pi over 6? Well, you're going to go to pi over 6, which is at 30 degrees, so down here, and the x value is root 3 over 2. However, I'm not going to ask you what the x value is. I'm going to say, what is the cosine value of pi over 6? And the cosine value corresponds to the x-coordinate, so we would say root 3 over 2. So let's look at a couple of examples of this. So find each of the following values. So the first one is sine of 60 degrees. So remember, 60 degrees is an angle because angles go into trig functions. So what this is saying is, at the angle 60 degrees, what is the sine value? And the sine value is, well, let's go to 60 degrees. 60 degrees is right here. Sine corresponds to the y-coordinate. So sine of 60 degrees is just root 3 over 2. Easy enough, hopefully. Moving on, cosine of 4 pi over 3. This time, cosine is the x-coordinate. So we want to go to 4 pi over 3. 4 pi over 3 is down here. The x-coordinate is -1/2. And that's it. Okay, I'll do one more together. Cosine of 7 pi over 6. Again, cosine is the x-coordinate. So 7 pi over 6 is over here. The x-coordinate is -root 3 over 2. All right, so here are 6 more examples. Why don't you try these on your own? In these ones, it's okay to look at the unit circle. So see if you can figure out what the coordinates are that correspond to each of these trig function values. So my suggestion is pause the video, see if you can figure these out, and then hit play, and you'll see the answers. All right, so these are the answers. Hopefully you got these correct. At this point, when you're just learning the unit circle, it's okay to refer and look at the unit circle in order to find these coordinate values. However, going forward, you're going to need to be able to do this from memory. So we'll talk more about how you can do this, kind of some strategies. But if we look back at the unit circle, really all you need to do is remember what's happening in this first quadrant here. Because if you can remember what's happening in the first quadrant, everything else just is a mirror image of what's happening in the first quadrant. So if you can remember what the coordinate values are at each angle and which angles we are dealing with, all of that maps to quadrant 2, 3, and 4. So what I recommend to students is that certainly you can try to memorize the entire unit circle. However, I would focus on remembering what's happening in quadrant 1, and then remember what signs each coordinate takes on. Is it positive or negative depending on which quadrant it's in? And what a lot of students will do on a test is they'll just draw out the first quadrant and label it all. And then they can use that as a reference. So 30 degrees, 45 degrees, 60 degrees. This is pi over 3, pi over 4, pi over 6. And then they write out what the coordinates are for each of those. Okay, so if you can get that down in the first quadrant, then hopefully everything, you can kind of see logically how everything maps around the rest of the circle. All right, one last example for this video. It says find cosine of alpha if sine of alpha is 3/5 and alpha is in quadrant 2. Okay, so we have an angle alpha. It's in quadrant 2, and it says that sine of that angle is 3/5. So when we have an angle like that, it's always down by the origin. Now sine is opposite over hypotenuse, so opposite over hypotenuse. Okay, so cosine of alpha is going to be the adjacent side over the hypotenuse. Well, we don't have the adjacent side yet, so the adjacent side is down here. Maybe I shouldn't make it a 0. I'll just label it adjacent. Okay, so we're going to say 5 squared is equal to 3 squared plus the adjacent side squared. Okay, solving for the adjacent, I get 25 is equal to 9 plus ADJ squared. 16 is equal to ADJ squared. Square root both sides. So we get the adjacent side is equal to positive or negative 4. Now, because this is in quadrant 2 and cosine is negative, the adjacent side is going to take on that negative value. So this is going to be negative 4. So putting it all together, cosine of alpha is the adjacent side divided by the hypotenuse. And that's our answer.